Hello everyone, I'm Siddharthan. Today let's solve the second LeetCode problem where we try to check if a number is palindrome. So once you navigate to LeetCode site, you can go to this problems tab. And here we are going to sort this based on the difficulty. And we have also seen how we can kind of solve this first problem of adding two numbers in a list. And the second problem that we are going to solve is, as I said, palindrome number. So I hope that you know what a palindrome is. So it's basically a number or a string that can be reversed. So in this case, if you see this right, so the number is 1 to 1, 121, and if you reverse this, it's also the same 1 to 1. And you have this another number called as 10, right? If you reverse it, the number would be 0 and 1, and this is not like a valid palindrome. So it's basically like it reads as they have given here. So 1 to 1 reads as 1 to 1 from left to right and from right to left. So this is the explanation. And here given an integer x, return true if x is a palindrome and false otherwise. So this is like the expectation, and this we can solve it in Python. And one easy way to do is convert this integer into a string and check if it is if that string is a palindrome or not. And the problem with that is like that's not efficient in solving, and that could also take like longer running time and longer or larger memory. So and it also doesn't have like that good of an approach to solve it. So instead we are going to like kind of solve it from scratch instead of like trying to convert it to a string. So we are going to apply some logic to find if a number is palindrome or not. And the other one is like the negative numbers are not palindromes. So we can just say that, put an if condition saying that if a number is less than 0, we are going to say that it's not a palindrome. So that's how we are going to work. And here you can choose a programming language of your choice. So I'm going to go with Python. And here first let me put an if condition saying that if x, so x is like the input number that they are going to pass. And let me close this one, can increase the zoom so that it's like clear to you. Okay, so if x is less than 0, that means if the input number is a negative number, we are going to say that it's a false. So because that cannot be a palindrome, as this case, right, minus 1 to 1 cannot be a palindrome. And next step is we are going to check if a number is palindrome or not. So this is where we are going to basically kind of fix the approach and solve it. I have my PyCharm open because this is like a bit complex to understand this approach, and it's like not kind of suitable to run this here because like the debugger is like available only in the premium option. So I'm just going to solve the same thing in PyCharm where I can access the debugger and I can like explain this to you in a better way. So here maybe what we can do is create this function called as is palindrome, the same one that we have over here, or maybe I can just show you this thing. So the first step is finding the last number. Okay, so how we can find the last number is, let's say that we have a number as x and this x has the value 1 2 3. And if you want to find the last digit, what you can do is say last digit is equal to x percentage of 10. So this x percentage is nothing but we call this as modulus operator. Again, these are like basic Python operators. So what this x percentage 10 will do is this will divide this x by 10 and it will give you the remainder. So in this case, if you divide this 1 2 3 by 10, right, so the remainder that you would get is, let's see, print last digit. And we see that 3 is the remainder, right? So because when you divide this by 1 2 3, so the result that you would get is like, so we would kind of, the output is like I can just show this to you. So when you divide this x by 10, the output that you're getting is 12.3. But we actually would be having a remainder, right? Instead, like if we don't want to go to this floating point, so for that we can use this percentage operator or modulus operator that would give this remainder of a division. And in this case, we can kind of use this modulus operator to get the last digit. So I'll run this. So you would get the last digit as 3. So this can be any number. I can have this 10 as the number. So if we divide this x by 10, right, so the remainder will be 0. But it is also another way of getting the last number. So let's say that I have a large number of 1 2 3 4 5, and let's kind of do the same thing and we would get the last number. So what we are trying to do here is get the last number of the given input number, remove this from the original number, and use this as the first number and build your reverse number. So that's what we are going to do. So the next step is, so the step one is to find the last number, and the next step would be to get the last digit using modular. Okay, that we have already done. And step two is remove the last number using floor division. So this, we found the last number using modulus operator. Again, just getting the reminder, if it is a string, right, we can just kind of use the length of the string in order to remove the last. But again, kind of converting the integer into a string, that's what I say, it's like memory, it's not like memory efficient, and it's going to take like a bit of runtime. So that's why we are not doing that. And then, so we are going to remove the last digit using floor division. Floor division is nothing but, I can say, let's say y is equal to 1 2 3 4 5. If you just divide it by slash, it's going to divide it, right? But when you use like double forward slash, it's what we call as floor division. And what it does is, if you divide 1 2 3 4 5 by 10, right? So maybe I'll comment this and I'll show this to you. Let's call this as quotient or something. So quotient is equal to x divided by 10, and let's print the quotient. Okay, so here we are basically dividing this 1 2 3 4 5 by 10 and trying to look at the answer. So the output is 1 2 3 4.5. What does this floor division does is, it will kind of do the same thing but round this to the closest whole number. So in this case, the 5 would basically drop off. So here I'll uncomment this. I'll show you this both quotient as well as y. Okay, so now let's run this. So okay, I have to print this y. So this we can use in a way in order to remove the last digit. As I said, this is basically used to do this quotient thing and floor division and so on. But when we divide it by 10 and kind of do the modulus by 10, we can use it for other purposes like finding the last number, removing the last digit and so on. So this is like the crucial logic that we are going to use. So the next step is removing the last digit. So the main idea here is, we would put this in a for loop so that at each step we would kind of get the last digit, remove that last digit, and kind of use those as the reverse numbers, and finally check if those kind of match. So that's what we are going to do. So the final step is using the last digit at each iteration of the loop, build the reverse number. So once we build it, we check if both the numbers are same. Okay, so build the reverse number and compare it with original number. So this is what we are going to do. So now let's kind of write this function. Can use this same function name called as is palindrome. So I'm going to say diff is palindrome, and here we are going to pass x as our input, and then we are going to say if x is less than 0, that means if it's a negative number, we are going to say that return false. And again, so this, once the x is like a negative number and we have returned false, the other piece of the code won't kind of run. So I'm not going to kind of have an else condition for that purpose. So instead we can just have like other statements checking if a number is like a positive number. We are going to check if it's a palindrome, so you don't actually have to put a else statement here. So here I'm going to initiate this reversed number. Okay, so let's say this we are starting this reversed number as a 0, and I'm going to store this original number, which is x, in a variable called as original num, because we will constantly change this x by removing the last digit, and basically for that purpose we are going to retain this in the variable original number. And while x is greater than 0, it's okay if you don't clearly understand this. So once I run this on debugger mode, you'll be able to see like what's the value is at each iteration. So that should be like more clear. So here I'll say last digit, or you can just use like simple terms like just digit instead of last digits. So last digit is equal to x percentage 10. So we are doing this modulus operation, and then reversed number is equal to reversed number into 10 plus last digit. So this is the part where we kind of start with 0 as a reverse number, and as we get this last digit we try to kind of build this number in a reversed way. I'll tell you like how this would work. Before that I can just complete the other pieces of the code. So I'll say x is equal to x divided by 10. As I said, this part is what we call as floor division, and this we are doing in order to remove the last digit. And finally, once this while loop is completed, we can return the original number is equal to reversed number. Okay. So this basically returns a true or false. So this is a comparison operator, right? So here we are basically checking if the original number is equal to the reverse number. If we are considering 1 to 1 as a number, the original and the reverse number would be the same, and we would get true. If the number is 1, 2, 3, 4, 5, of course it's not a palindrome, and it would return a false. So here I'll call this function as let's say this is my output, so I'll call this as op and is palindrome, and I'm going to pass 1 to 1. So this should, and then I can print this op. First let's run this and check if you're getting the true and false properly. So 1 to 1 is like a palindrome, we are getting this as palindrome. If I put a negative symbol, so we already have a check mark for negative numbers, so this would return a false, right? And I'll just take another positive number that is not a palindrome, so it can be, let's say, 1 2 5 6. So this is not a palindrome, right? So I'll take this. This is also false. Let me take another palindrome, the one that they have given, 10 1 to 1. Let's see if there are like any other test cases. Okay, but yeah, let me take some other thing. Okay, 1 2 1 2 1. This should be a palindrome, right? So we're getting true. So now let's kind of put this in debugger and see like how this reverse number of 10 plus last digit like basically works, and understand this in a better way. So I'm going to put a debugger. So this is like the interesting thing about PyCharm, and like really helpful feature is that you can use this debugger in order to check what's the value of a particular variable is at each point of the code. So if I just put, so you just have to, if you haven't used PyCharm, right, so basically you can install it and try this code, and beside this serial number, if you kind of take your cursor there, you will see this red dot. So this is what we call as breakpoint, and once you have fixed this, so you can basically have multiple breakpoints in your code, and once you have your breakpoint, you see this debug check.py file, right? So you can click this debugger option. Once you click it, so your code will execute, but it will stop before executing this line. It will stop at my breakpoint, which is line number 9. So it's mentioned here. So at line number 9, before this line is executed, while x is greater than 0, it's executed, right? We are seeing the value of original number. So here also you can see original number is equal to 1 to 1 to 1, and the reverse number is equal to 0, and x value is 1 to 1 to 1, the number that we are passing. Maybe I can take a simple number so that it's like you can understand this easily. So I'm rerunning this. Okay, so first we have the original number. Original number is nothing but a copy of x, right? So it's like 1 to 1, and the reverse number we are initiating with 0, and x is equal to 1 to 1. We don't have any other variable set. Now you have other options. So you have the step over to skip a particular line and go to the next line, and you have the step into. So this will go into each line of the code. If you are using a specific library, it will go into that code as well. And you also have the step into my code where it will just like run your code one line after the other. If you are using some libraries, it won't go into the function of that library. So here I'm going to use this step into my code to run this code line by line and see how my variables are changing. So let's run this step into my code. So this line number 9 is executed. Here we are not kind of changing anything. So here we are checking if x is greater than 0. So it's of course greater than 0 because the value is 1 to 1, and now line number 10 is getting executed. So it's waiting to execute this line number 10. So I'll again press this step into my code. Now we have this last digit, right? So last digit value is 1, because we know that once we kind of do this modulus operator, we know that this would return us the last number. In this case, the last number is 1 in the 1 to 1 thing. So we get the last digit as 1. Next step is reverse number is equal to reverse number into 10 plus last digit. So here what you would get is, again, this is to reverse your number. In the first run, the reverse number value is 0. So you multiply 0 with 10. So you would get 0 here. And we would add last digit to that. And last digit is nothing but 1, right? And I'll do the step into my code. So the final value will be 1. So here your reverse number is 0 before running this line, and once this line is executed, we are seeing the reverse number as 1. And then x value previously is 1 to 1. Now we are going to use the floor division in order to remove the last digit. So once I run this particular line, my x value should change from 1 to 1 to 1 2. So I'll run this. So now my last digit has kind of disappeared. So we have removed it and we have the x value as 12. Now we again kind of execute this while loop, do the same thing. So here your all the values are updated, right? So your reverse number has become 1. Original number is same because we have copied it already, but your x value is now 12. So we have changed it, and your last digit is 1. So we run this code again. Now your last digit would change from 1 to 2 because previously your x was 1 to 1. Now it's 1 to. So let's run this, and your value would change, last digit would change to 2. Now think about how your reverse number would change. Previously your reverse number was 1, right? Now we would multiply this 1 with 10, so you would get 10, and add the last digit 2, so you would get 2. So this is how we are reversing our string. And once you kind of run this, your reverse number would change to 12, and all the other things are same. Now your x is 12. Now we would remove the last digit, which is 2. So once I run this, I should get 1 as the value, so as you are getting. So you would do the same step again. Now your x would change from 1 to 0 because it has like removed that last digit, so you don't have anything, so it's a 0. Now it checks if your x is greater than 0 or not. Your x is actually not greater than 0, it's equal to 0. So this while loop won't run at all. So let's step into our code and see that now these lines have not executed, right? Because the condition has not satisfied. And now we are going to return this thing. So original number is equal to reverse number. Again, as I said, this is like a comparison thing. So in this case, the original number is 1 to 1, reverse number is 1 to 1. So it will like return true. But if we take this minus 1 to 1, right, or like some other numbers that are not palindrome, you would see this thing where, they are not same. Maybe I can show you another example where I'll have a breakpoint here at the final return statement. And let's stop this and put this 1 to 1 first and run our debugger. So this would stop at the return statement. So original number is 1 to 1 and the reverse number is 1 to 1 as well. Now let's stop this again and run this. Sorry, so change this to 1 2 3 4 5. So here when you run this on debugger, your original number is 1 2 3 4 5, and we have reversed our number successfully to 5 4 3 2 1. So we compare these two, so these are not same, so it would return the false here. So you can just run this thing where resume program, so this won't stop anywhere. So this will like kind of continue to run the program, and you will see the result. So when you have this 1 2 3 4 5, it's going to say that it's kind of not a palindrome. So this is how you can build this code to check if a number is palindrome or not. And the important thing is not to convert this to a string, so that we have like a more efficient program. So I know that we are kind of trying to take a lot of time and understand this, but again, you probably won't have this much time in your interview time where like you need to solve this question in your technical round. But this is the first step for it. So here we try to understand this more clearly, and the next time you see this, you may not remember this quickly. So you have to practice these questions a lot, understand the approaches clearly. That's the main thing, and that's how you can solve this quickly. And apart from solving this in interview, right, the other important thing is you kind of get better in the aspect of programming itself, right? So that's other takeaway I would say from understanding or kind of solving these LeetCode questions. So with that note, let's kind of type the same program in our LeetCode and try to see like what's the result we are getting and if we are passing like all the test cases. So here I'm going to say reversed number is equal to 0. So we are initiating it, basically the same code. So original number is equal to x. So we are saving a copy and creating a while loop where if while x is greater than 0, we are going to run this loop. And here last digit. So instead I'm just going to say digit. So digit is equal to x percentage 10, which is the modulus operator. Let me just remove all the unwanted spaces maybe. Okay, so the digit is equal to x percentage of 10, and we know that we are doing this in order to get the last digit and save it to the variable digit. And now we are going to start reversing the number. So reversed number is equal to reversed num into 10 plus digit. And then we need to update our x, where we remove the last value of x by saying that x is equal to x floor division of 10. And once the while loop has kind of ran, we are going to check if original number is equal to reversed number. So this will either return a true or false. As I said, if the number is less than 0, it will return this false and this code won't execute at all. But if x is a positive number, this part will be skipped and we run the other part of the code. So that's why we don't have an else statement here. Okay, so this is our code. Let's save this, and you can run this in order to kind of test it with these 3 test cases. And once you submit it, it will be kind of validated with other test cases, because let's say that your code works with these 3 test cases, but there is like some bug and you're still like away from making like a proper code. So that's why they check it with other test cases as well. So let's run this. Let's see if our test cases are getting passed. Right, so you can see it says accepted, and you can see this green dots. So the expected output is true for this number. We are saying also like returning true, and in this case like -121 should say false, and we are getting the expected result. Same for this, right? And once you get this kind of get approved for this test result, you can do this submit thing, where this code will be validated against like other test cases, and you will see the result here. So this is like the runtime, and in this case it's taken quite a bit of a runtime. I can submit it again. Sometimes like the test cases may change and you can see like a better performance as well. But yeah, so this is the idea of solving this, where we basically try to remove the last digit, kind of get it in a variable and reverse the string, and finally check if it's the reverse string is like the same as the original string. So I hope everyone is clear with this aspect, and I'll see you in the next upload. Thanks for watching.